have details about the wheel alignment. Let us go to the wheel alignment. Why wheel alignment is very important. Okay, if you don't have the proper wheel alignment, the vehicle will be pulling towards one side. Okay, you will have instability basically. Um, and there's also a sign of a poor wheel alignment. If you have the poor wheel alignment, then it will lead to a vehicle which will pull to one side, and this will also create uneven tire wear, tread, and also steering wheel is off-centered when driving straight, and then it will also experience some of the steering wheel vibrations as well. And this wheel element is a critical set of design and maintenance parameters. And these parameters have to be maintained in a specific design range, such a way that it will ensure a vehicle performance, and also it will help for maximizing the life of the tire. And this also has an impact on the cornering, straight line performance, and also the tire wear. So hence this wheel alignment is very much important. And what we have seen is the camber. Camber is the one. What we have seen is that when you're viewing the vehicle from the front of the vehicle, what happens? The angle which is made by the tire or the wheel. So this is assuming that this is a tire and the wheel. The angle made by the wheel and tire with the vertical direction. So this is the vertical direction. Okay. This is the center wheel plane. Okay. This is center wheel plane. And this angle, what we call as a camber, when you're viewing the vehicle from the top of the top side. Okay. And you have two type of camber. One is positive, and one is negative. If the top of the vehicle leans away from the vehicle body, so if it is leaning away from the vehicle body, you can see here this is the positive camber. And if in case if the top of the wheel is leans towards the vehicle body, you see here if this is leaning towards the vehicle body, then it is called as a negative camber. Okay. Positive camber is the one where this is leaning means it is leans away from the vehicle body, and this negative camber is the one which leans towards the vehicle body. Okay, so this is the difference that you need to understand. And now this negative camber is much better for a better grip during the cornering. Basically, it helps during the cornering. And if the camber is out of adjustment, it will cause severe on one side, and also if the camber is different from side to side, it will also lead to vehicle pulling on one side. So let us see what is caster. Okay, so it is the angle made by the steering axis. So this is the steering axis, the angle made by the steering axis with the vertical direction. So this is vertical direction. When you are viewing the vehicle from the side of the vehicle, so you are viewing. I am viewing the vehicle from this side, and the angle made by the steering axis with the vertical direction, you call this as a caster, and you have two caster. One is positive and negative. And when the steering axis is leans towards the rear of the vehicle, when it is leaning towards the rear of the vehicle, this is the front one. Okay, so when it is leaning towards this, you have a positive, and when the steering axis is leaning towards the front of the vehicle, okay, so when this is leaning towards this, leans towards it, then it is called as a negative caster. And you know that positive caster is resulting in the trailing, that it also creates a self-trailing aligning torque, and it also helps for the better stability because of self-aligning torque and high steering effort. And you also have parameters where the caster is also help for better maneuverability. If you have a high caster, then you have high steering effort and lower maneuverability. And you have a important parameters called toe. Let's see what is toe. Toe is basically a wheel alignment parameter which influences the tire wear and also the straight line behavior and also the cornering characteristics. Excessive, if you have excessive toe, it results in excessive more tire scrubbing, leading to the higher tire wear. And the toe is also it helps for it also results in better straight line stability. Toe in basically, toe in helps for better straight line stability, and toe out provides a faster steering, cornering response basically. So let's see what is toe in or toe out with respect to the wheeling parameters is concerned. Let's see that. So what is toe? Toe is like this is the vehicle, okay? I am viewing the vehicle or the car from above. Okay, this is the car. I am viewing the car from the above. Okay, you assume that this is the top view basically. When I'm viewing the vehicle from the above, it's called sorry. So it's basically a bottom view. Okay, because you are seeing the vehicle from the top and you are viewing it down. Okay. Uh, so you are standing in the car which is above, and when you're viewing it from above the car, what happens? Uh, this will be the view. Okay, this is the view, and this is the front end of the car. You're considering only one wheel. Means one two wheels of the front side. Okay, and this is the front end of the front wheel, and this is the rear end of the front wheel, and this is the front end of the front wheel, and this is the rear end of the front wheel. Okay, now you see here. What is tow? Tow is nothing but when you viewing the vehicle, when you're viewing the when viewed from the top of the about a car, so it is nothing but the difference between the trailing and leading and trailing edges of the front wheel. Okay, um, so you have two edges. One is leading edge and another one is the trailing edge. Okay, and you see you also have an angle. You see this is the angle which is made by the central wheel plane. Uh, so this is the this is a central wheel plane. Okay, this is a central wheel plane. It is expressed in red. Okay, this is central wheel plane to the with respect to the longitudinal axis. This the pink one is the longitudinal axis. Okay, and this is the central plane of the wheel plane. Okay, so the angle which is between the central wheel plane highlighted in red and the longitudinal axis, which is in pink, you call the angle between these two, you call this as a toe angle. Okay, and you have two terms. One is toe in, and another one is toe out. And leading edges and trailing edges. So you see here, uh, leading edges is the one where it is leading away from the the wheel. Okay, leading means what you call the distance is away. Okay, and trailing is nothing but the one uh, the angle or the toe angle, the angle between the center axis to that of a longitudinal axis is very near basically. So let us see what is leading and what is trailing with respect to toe in and toe out. So toe in is nothing but the leading edges of the front wheel. This is the front wheel are closer to each other. They are closer to each other um, than the trailing edges. Okay, and vice versa, you have the toe out, which is nothing but the trailing edges of the front wheels are closer to each other than the leading edges. Uh, so in toe in, you have the leading edges, which is on the upper hand, and the toe out is the one which where you have the trailing edges as the upper hand. And you also have some other parameters called SAI, which is nothing but the steering axis inclination. How you can call how you can define the term SAI, which is nothing but the steering axis inclination. You see here, this is the spring, or you call this as a shock absorber, uh, or the suspension. Okay, and this is the wheel. Okay, and we seen that this is a steering axis which is highlighted in green dot. Okay, and we also know that this is the center of the suspension system, okay, our spring system. So the angle made by the steering axis with the vertical direction. Okay, so this is the vertical direction of the suspension. So with the vertical direction, when viewed from the front of the vehicle, you call this as the steering axis inclination. Okay, and this steering axis inclination is also called as kingpin inclination. We have seen that in the case of the commercial vehicle, we have a kingpin, and in the case of the passenger car, we have a ball bearings. Um, so in the case of a commercial truck application, we call as a kingpin, and we also have that term as kingpin inclination, where this kingpin inclination is also called as steering axis inclination. Steering axis inclination is denoted as CCI, and kingpin inclination is denoted as KPI. And it is kingpin KPI or SAI is nothing but the angle made between the steering axis with the vertical direction when you are viewing the vehicle from the front. You have two more parameters. One is sorry, three more parameters. One is the setback. Sorry, the included angle, scrub radius, and the setback. So what is called included angle? We have seen in the previous slide SAI, where it is the angle made by the steering axis with the vertical direction to that of the steering axis. See now you have three terms. One is included angle, camber, and steering axis inclination. So what is camber? You see here, we have seen the definition of camber, right? Camber is denoted as 1. Okay, and what is camber? You see here, you also seen what is positive camber or what is negative camber. Okay, so this is the one. One is the vertical axis, another one is the center plane of the wheel. Okay, see now you see here. Okay. The angle made by the wheel or tire with the vertical direction, this vertical direction, when we are viewing it from the front of the vehicle. Okay, so this you call this as a camber. That's what is mentioned as camber. Okay, this is the vertical direction. This is center of the wheel plane, and you are viewing the vehicle from the front. And what we have seen as a SAI, SAI is also we are viewing the vehicle from the front. Okay, and the angle between this an angle between the center of the suspension spring to that of the vertical direction of the vehicle, you call as a steering axis inclination. Okay, this is the steering axis inclination. And what is the included angle? It is nothing but the summation of 1 and 2. Okay, how I can call? I can call this as the angle between the steering axis. Okay, you call this as steering axis and the central wheel plane. Okay, this is the center wheel plane, right? The red one, center wheel plane. So how we can define this included angle? It is nothing but the angle between the steering axis and the central wheel plane. We call this as a included angle. And now what happens? We have also seen negative camber and positive camber. Okay, see how I can define. You see here, when you have a SA high, which is nothing but this is the SA, right? When you have a higher SA high, which means the distance between this steering axis to that of the, the vertical direction, the red one, okay, it increases. When you have higher SAA, what happens? It is nothing but a positive camber. Okay, we have seen, right? What is called positive camber? When this shifts here, this also shifts here. Okay, as a result, what happens? Improve the angle or the camber becomes positive. And when you have lesser SAA, what happens? This less reduces, and similarly, this center plane distance and the vertical direction, it moves towards this side, which means you have a negative camber. Okay. Now we have two more parameters. One is the scrub radius, and this scrub radius is nothing but the distance between the point of intersection of the steering axis. Just a second. You see here, I am extending the line for this center plane down. Okay, and I am also extending the center axis here. You see here, I'm also extending like this, and you have when you draw the line, straight line from the ground, okay, you have the distance between which is there in the red, okay. You call this as a scrub radius, which is nothing but the distance between the intersection of the steering axis. This is the steering axis intersection and the center plane with respect to the ground. You call this as a scrub radius, and it's always going to be on the positive side. Okay, that's what is called as positive scrub radius. So what is called as a setback? Setback is nothing but what you see at this is the front wheel, okay, this is the rear wheel, and what happens if you assume that this is the left wheel, this is the right wheel of the front wheel. You see here, this is the right wheel of the front, and this is the left wheel. You have some gap. Okay, you can see you have like wheel gap, and you call this as a setback, which means one front wheel is behind the other. Okay, other which is and this will also lead to uncentered steering. Okay, because you don't have centered steering where it is even, it is uncentered steering. And you also have one more term called crest angle, okay, or you call this as a crest line. See, during cornering, what happens is the front wheel of the front side, and is the rear wheel of the front side. Um, if you have a term called crest angle, where you're assuming that this is the longitudinal axis, okay, it's the longitudinal axis of the vehicle, and the angle made by the rear wheel. So this is the rear wheel, okay. The angle made by the rear wheel with the center line, the center line of the vehicle, this is the center line of the vehicle. Okay, this is the center line of the vehicle. Along the longitudinal direction, when you are viewing the vehicle from top, from above the vehicle. So I am viewing the vehicle from above. Okay, and what happens? I have a longitudinal axis. This is the longitudinal axis, and I also have the angle. See what happens. This is center line basically. This is center line. The data one is a center line. What happens? You can see there is a shift happening in the rear wheel. Okay, because it is not straight like front. As it is getting towards the right, right direction, what happens? Longitudinal axis remains same. What happens? The center of center line it gets shifted, and you call this as the thrust line, and the distance between the angle between the thrust line and the longitudinal axis you call it as a thrust angle. Okay, if you have a non-zero thrust angle, it leads to uncentered steering. Um, so here the steering is not centered, right? So, and again, it is not, the angle is also not zero. Okay, that's why if you have a non-zero thrust angle, then it is, the indication is that it leads to uncentered steering system. So it's always better to have center the steering such a way. Uh, but again, it is not. It is highly theoretical, or it is highly impractical for us to achieve a non-zero, because there are some cases where during cornering, and then during a sharp cornering or round cornering, what happens? This phenomenon is going to happen. So that will also a problem for a wheel alignment. So this is also one of the parameters that needs to be taken into consideration. So what are all the wheel alignment parameters we have seen? So this includes camber, where we have seen what is positive camber, what is negative camber. And next comes the wheel alignment parameters called caster, where we have seen positive caster, what is negative caster. And we have also seen next parameters called toe, in which toe in and toe out are been steadied. And next called steering axis inclination, or KPI inclination. And next we have seen include angle, what is include angle, what is curb radius, and then what is setback, and what is thrust angle. So these are all the various wheel alignment parameters that needs to be taken into consideration, because in order to have a proper cornering style and performance, and to uh, have a less impact on the tire wear. Okay, if in case if these parameters are not been maintained, then you will face a problem of vehicle pulling to one side, and then uneven tread wear, and then the steering wheel is not in center when you're, even though when you're driving the vehicle in straight condition, and you'll also have the steering wheel vibration as well. So these wheel alignment parameters are very much important with respect to the steering performance, and then the systems is concerned. Okay, so this is all about the wheel alignment.